So I have recording started. Okay, recording started here. So here again, I took from the same book, but don't confuse here. Before starting to the Fourier transform, let this one, and I have already uploaded this study material, integral transforms. See, there are a number of integral transform. The name is called integral transform because all this transformation is based on integration. Whatever topics, the Fourier transform is only one part of the integral transform. There are Laplace transform, there are a number of transforms are there, but Fourier transform is one of them. The name is called the integral transform because all the transformation is based on integration. So those who are very weak in the integrations, you are not able to do the Fourier series, you are not able to do the Fourier transform. The new students, those who are coming, please practice integrations. What are the property? What are the rules of the integration? How I do the integration by parts? These are the very much important in case of unit number 1. Totally, we require the complete concept of integration. So part 1 we have completed. In the part 2, we have to transform from time domain to frequency domain. Here also it is completely integrations are here. So integral transform does not mean only Fourier transform. Integral transform has number of transformations are here. What is the application of it? One of the applications I speak to you that if we want to do the filter of the signal, means I require some particular frequency only. Very good example is that in the FM radio, it has particular number of frequencies, right? So at particular frequency, we can get only one particular FM station. Different frequency, we have different FM stations. Same thing here in geophysical data processing also. As per the requirement, we require the different frequency level. So we have to filter out sometime. We have to sometime high pass filter, sometime low pass filter, sometime we require the bandwidth filters. That's why we have to transform from time domain to frequency domain, because the time domain, it is very difficult to see the frequencies. This is one of the application. Second application is that we can solve partial differential equations with the help of Fourier transform. Okay, with the help of Fourier transform, we can solve the partial differential equation. Because the partial differential equations, if I want to solve the wave equation, see, generally in the petroleum science, if we talk about the seismic method, all the energy are travel in the form of wave energy. So if I want to find out the energy travel interior of the earth, we have to solve the wave equations. The wave equation is a partial differential equation. Now, without help of Fourier transform, without help of Laplace transform, some of the engineering problems cannot be solvable. Engineering problem means the calculation is very much critical. Textbook problem means the problems are very systematic, apply the formula and you can get the answer. Engineering problem means the textbook problems can be applied, but it requires lots of calculations. Very difficult to do the calculations. In engineering problem, we have to use the integral transform. I'm not talking only about a Fourier transform. To solve the partial differential equation, to solve the ordinary differential equations, we require the integral transform. It may be Fourier transform, it may be Laplace transform. Both are very much important. In our syllabus, we have the Fourier transform. Now, if we read here, integral transforms means it may be Laplace, it may be Fourier. Number of integral transforms are here used in the solution of partial differential equation. The choice of a particular transform to be used for the solution of a differential equation depend upon the nature of the boundary condition of the equation and the facility with which the transformation Fs can convert it to the Fs. Fs maybe it is in terms of frequency. Fx means Ft, it is in terms of time. So what we do that, in case of integral transform, first we do the integral transform. After that, again we have to do the inverse of the integral transform. In case of Laplace also, we have to do the inverse transform finally. In case of Fourier also, we have to do the inverse transform at the end of the answer. So if somebody asking that why we required integral transform, why we require the Fourier transform. So today I am giving only two answers. There are a number of importance. Out of number of importance, I am giving two. First is that we have to do the frequency analysis. Second is that we have to do a solution of partial differential equation. Why? Most of the engineering problems are in the form of partial differential equations. For example, if I want to solve the reservoir time gradient, means I want to find out the heat diffusion equation, right? If I want to solve the heat equation, the heat diffusion equation, wave equation, these are the some of the engineering problem happening in the reservoir engineering. In case of reservoir engineering, we have to solve the wave equation, which is partial differential equations. That time I need help of the Fourier transform. Second, if I want to solve the heat diffusion equations, heat equation in terms of thermodynamics, then the equation of heat diffusion is again in terms of partial differential equations. In that case also, I require the Fourier transform. How? I'll discuss in this section how the Fourier transform is helpful to solve the partial differential equations, right? And it is in terms of engineering problem. Second is that to apply the integral transform, that particular differential equation should be initial value problem or boundary value problem. Initial means the values of x naught should be given or values of t naught should be given, and values of suppose t15 means at the end of the 15 second should be given. So initial value and finals are given, which is called the boundary value problem. Only initial values are given, this is called the initial value problem. Okay, so we have Fourier transform. How many forms are here? Look here. Laplace transform, this is also called one type of integral transform. Fourier complex transform with kernel, this is one type of integral transform. Fourier sine transform with the help of kernel, this is also one type of Fourier means integral transform. Fourier cosine transform with the kernel, this is also one form of our integral transform. Hankel transformation with the kernel, this is also one type of integral transform. Okay, next 6 Hilbert transform with the kernel, this also one type of integral transform. 7 point is that Mellin transformation with kernel. This 1 to 7 are the total integral transforms. So we have total 7 type of integral transform. Okay, so out of 7 we have to do only Fourier transform. If I do the Fourier transform, then we can do the classification of sine Fourier transform and cosine Fourier transform. But at the beginning, we'll discuss first in general what is a Fourier transform. Then after getting the concept of the Fourier transform in general, we'll do sine Fourier transform and cosine Fourier transform. We don't have complex Fourier transform at present. We have only Fourier transform in general. Second, we have to talk about the sine Fourier transform. Third, we have to talk about the cosine Fourier transform. Okay, so we have mainly 3. In general, Fourier transform. Second is sine Fourier transform. Third is cosine Fourier transform, and how we have to solve the partial differential equations. These are our main topics we want to cover in a section 2. So integral transform, total we have 7 type of integral transform. Okay, this 7 type of integral transform, can be implemented as per the requirement. As per the situations, we have to apply Fourier transform, we have to apply Laplace transform, we have to apply the Hilbert transform, we have to apply the Milnes transform method. So there are a number of requirement and number of conditions. But in semester 3, we have Fourier transform only. Okay, Fourier transform will classify mainly two: sine Fourier transform and cosine Fourier transform, and application of sine Fourier transform, cosine Fourier transform, and Fourier transform in general. So look here, these beginnings are not our part of the syllabus. See here, these are I just introduced to all of you. These are not our part of the. See, these are not our syllabus. Our syllabus I'll discuss to you. Our syllabus is coming here directly. Our syllabus is Fourier series. So don't confuse. All beginnings are not in our syllabus. Our syllabus is coming here. This is the Fourier transform. Have you seen here? So the Fourier transform is our syllabus here. Okay. Fourier transform. Out of 7 integral transforms in our syllabus, we are only Fourier transform. Fourier transform is the part of integral transforms. Okay, all the Fourier transform, everything are derived from the integral transform. Okay, but here we are not going to derive the Fourier transform. We are going to remember what is the formula of the Fourier transform. We have to just remember it and we have to apply it. So there are a number of derivations. This line is equation 1, 2, 3. This is, we don't want to remember here. We want to remember which is written inside the box. We want to remember this inside the box. The first equation, capital Fs is equal to capital F of x, right, is equal to capital Fs. Some books they write the omega, capital F omega, because mainly Fourier transform is time domain to a frequency domain. That's why capital F instead of S we write the omega. Capital F of small ft, most of the case become in terms of time domain, f of t. By the textbook we write f of x. Capital F of x means Fourier transform of this f of x. Capital F of small f of x signify Fourier transform of f of x. The formula is 1 by square root of twice phi integration minus infinity to the infinity f of t into e to the power ist dt. This I means iota. Okay, this first is called a Fourier transform. Okay, this first line is called the Fourier transform of f of t. Look here, we do the integration with respect to t because most of the f of x is become in terms of f of t in general. But in the textbook it is written f of x. Capital F of s it is in a textbook, but in general it has become capital F of omega. Omega signify the angular frequency. Okay, so this first line is called the Fourier transform. So you have to note down this one. This second line, the second formula is called the inverse of Fourier transform. Inverse. In the box, the first equation is called the Fourier transform. We have to do here integration with respect to time. Inside the box, the first equation is called the Fourier transform. Inside the box, the second line is called the inverse of the Fourier transform. If it is Fourier transform, the output will be in terms of s or in terms of omega, means in terms of frequency. In case of inverse of the Fourier transform, the output will be in terms of x or in terms of small t. The notation of Fourier transform is capital Fs. The notation of inverse Fourier transform is small f of x. So this is the only difference here. But don't confuse. Some are books they write this is omega. They replace s by omega. Okay. Some book they replace s as a omega. So f omega into e to the power minus I omega x into d omega. So don't confuse. If I read the multiple number of books, we can get two different type of notations. Okay. The first equation is called the Fourier transform. Second equation is called the inverse of the Fourier transform. Okay. So this is the formula we have very much important. If anyone is saying something, okay, not. Now come up here. Fourier sine and cosine transform. Okay. If we look the integral transform, I had noted down the sine Fourier transform and cosine Fourier transform also in the list of integral transform. Okay, so we have mainly in our syllabus a Fourier transform in general. Second, sine Fourier transform. Third, cosine Fourier transform. Okay, now we don't want to derive all these things. Just you have to note down here. Okay, the equation 1, I mean this equation 1 is called the sine Fourier transform of f of s. Please note down this one. Inside this big box, okay, this first equation is called the sine Fourier transform. F of s is equal to f of s is equal to square root of 2 by 5 integration 0 to 5 f of t into sine st into dt with respect to t. This equation is called the sine Fourier transform. Second equation which is f of x is equal to square root of 2 by 5 integration 0 to infinity f of s into sine s x into ds. This equation number 2 is called the inverse Fourier sine Fourier transform. So now we have two equations. First one equation was that now we have four equations. First equation was that in general Fourier transform. Second equation was inverse Fourier transform. Third equation is sine Fourier transform. Fourth equation is inverse of sine Fourier transform. These equations are very much important for all of us. Okay. Next we come cosine Fourier transform. Means total we have to remember 6 equations in case of Fourier transform. One is Fourier transform in general, inverse Fourier transform in general. Third is sine Fourier transform. Fourth is inverse sine Fourier transform. And fifth number is cosine Fourier transform, and sixth number is inverse of cosine Fourier transform. So total 6 equations we have to remember here. Okay. So this equation number 3, which is called, this equation number 3 is called the cosine Fourier transform. Okay. This equation number 3 is called the cosine Fourier transform. This equation number 4 is called the inverse cosine Fourier transform. Okay, this equation number 4 is called the inverse Fourier cosine transform. Okay, so these are the very much important for all of us. So I'm again repeating you. We'll start from the Fourier transform. Our syllabus only contained Fourier transform. Okay. Sine Fourier transform, cosine Fourier transform. Mainly we have 3 transform and their inverse. We have total 7 integral transform. The name is integral transform because in this transformation, totally integration is best. If I don't know the integrations, then I cannot do the transformations. That's why we should know the basic concept of the integrations. Okay. So out of 7 in our syllabus, we have 3 integral transform. One is Fourier transform. Second is sine Fourier transform. third is cosine Fourier transform and their corresponding inverse transform. What is our aim? From time domain to the frequency domain, we want to transform. Some of the books they write S, some of the book they write the omega. Once we transform to time to frequency, it is become omega. Okay, if I do the inverse transform, omega become again t. In this book they have written S. Okay, x become S in terms of Fourier transform. If I do the inverse, again S become S. So this equation, these two equations you have to remember, very much important. Second, these two equations we have to note down, very important. Again, these two equations are very much important. You have to note down. Okay. Now, example based on Fourier transform. At present, we are not talking about the sine Fourier transform. We are talking about the Fourier transform. Means formula we have to remember, which is general Fourier transform. Sine and cosine Fourier transform are special case of the Fourier transform. In the case of Fourier series also, we have three types of series. One was general Fourier series, second was cosine Fourier series, third was the sine Fourier series. Same thing here also, we have Fourier transform, cosine Fourier transform, and a sine Fourier transform. Look here, if they didn't mention anything, sine Fourier transform or cosine Fourier transform, it means that they are asking for general Fourier transform. If they are not mentioning that, आपको क्या करना है? Sine करना है या cos करना है? If they didn't mention anything, they simply write that find out the Fourier transform. It means I have to do only in general Fourier transform. They have to mention sine Fourier transform, then I have to do sine Fourier transform. They have to mention cosine Fourier transform. It means I have to do the cosine Fourier transform. If they are not mentioning, means I have to do general Fourier transform, means I have to apply our general formula here. Find a Fourier transform of the following function. It means I have to apply general. What is the function? F of x is equal to 1 if modulus of x is less than a. If it is 0, if the modulus of x is greater than a. So I have two functions now. I have two functions here. One, if it is in between it, 0 in between it. Now, the Fourier transform of the function f of x is given by how it is coming? It is coming from our formula. The formula was given capital F of small f of x, means Fourier transform of the given f of x is 1 by square root of twice phi integration minus infinity to the infinity f of x into e to the power I s x dx. Some of the book they write this is dt, okay. Some of the book they write this is t. Some of the book the s they have write omega. So don't confuse it. Look here in formula also. I have written here t dt, but the function is given f of x. So dt become dx, this t become x. So don't confuse it. If function is become given in terms of f of x, right hand side always become in terms of x only. See, this should be f of x, this should be dx, this t should be x. If function is given t, f of t format, then right hand side will be in terms of t. So don't confuse here. In this particular example number 1, example number 1, look here. Example number 1 here. In example number 1, the function is given in terms of f of x. The limits are given in terms of x, in terms of x. That's why the formula should be in terms of dx. The formula should be in terms of f of x. The t become here x. This is as per the formula. Okay. Now substituting the value of f of x in the equation number 1. Means I have to put the limit now here. Look here, 1 by square root of twice 5. Limit is given here. Modulus of x means what? Modulus of x less than a का मतलब है -1 to plus -a to plus a. Modulus of x is less than is equal to a means this is in between -a to a. That's why look here, limit is -a to a. F of x is it is given 1. So I have put the value of 1, f of 1, e to the power I s x into dx. In the second interval here it is 0. It means it is a to infinity. So the value of the function is 0 here. That's why plus it is become 0. Now I hope all of us can do the integration of e to the power I s x. Here s is constant here because we are doing the integration with respect to x. Here s is constant. If I do the integration, I can get e to the power I s x divided by I s. Both are constant. Put the limit. After putting the limit, I can get this is the equation. Now use our here formulas, complex number formulas, right? Now if I simplify it, I can get 1 by same it is. I can write this is 2 divided by s. This I cancel because I divide here. I adjusted this one. Here I have written 2i's I. So this 2i, this I can write here I cancel out. This 2 cancel out. So I can write this one. It means this is a sine a s. As per the formula of trigonometric, this formula is sine a s. So it is as it is 1 by square root of 2 5. This 2 is 2. Now this become sine a s. So sine a s. This s is as it is. After simplification, this is the answer. Look here. After doing the transformation, the f of x become capital Fs. F of x become capital Fs. Some of the book it is written in terms of frequency omega. This book they have written in terms of s. So don't confuse. It should be in terms of frequency. Time domain transform to the frequency domain if I do the Fourier transform. This is the one example we have completed. Okay. So today we are not going to go in the next example because time is already completed here because I want to discuss to all of you if you have some difficulties here. So I'm going to allow to all of you that you can ask if you have some difficulties here. Okay, now anyone getting confusion, please let me know, then we can clarify it.
Sir, on page number 1091.
Page number
1091.
Note 1.
1091, sir.
Yes, yes. Here, any confusion?
Sir, in the note section. Note.
Which one? Please tell me.
Sir, the note, the 1 by 2 pi we multiply by under root of 1 by 2 pi.
Okay, not. Okay. Why it is multiply, right?
Yes, sir.
Okay. Now, to understand this one, we have to go through all this derivation. How it is coming? It is coming from the previous. We didn't derive it. After multiplying here, we can get here is written that not for reasons of symmetry. We multiply both f of x and fs by this instead of having the vector 1 by 2 5 is only one function. Thus, we obtain the definitions of the Fourier transform. Where they multiply here. Here I have the regions of symmetry, we multiply both f of x by this here. I think here they have multiplied here, right? I think they have multiplied here. Both side here. I think they multiply here on the both side of putting this in this. They have multiplied here. We multiply both this by this. By 1 by this. In equation 1, after doing this one, equation 1 is coming like this. Simplify this. Okay. This multiplication, square root of 1 by 2 is fine. If I do multiplication on the both sides, suppose if I multiply here, means they're multiplying here. If I multiply in this side, why they are multiplying? If I multiply some constant terms on the left hand side and right hand side, there is no any effect. But what they are talking about the symmetry. They're talking about the symmetry means if I transform from the time domain to frequency domain. Here it is not mentioned very clearly. It is clearly mentioned there. Once we transform from time domain to frequency domain, actually it is transformed to S plus I sigma, which is a complex plane. In the basic level, it is not mentioned here. The most general, if we do the in general study, it is coming. Time domain is going to transform S, which is a real part, plus I sigma. Complex part and imaginary part, it is going to be multiplied. But now, if in case of Fourier series, if I take only real part, suppose S part we are here taking here, we are not taking about this complex part. Now to maintain the symmetry along the imaginary part, उसको हम अगर आप डिटेल्स करना है उसका डिटेल्स आपको थ्योरी बताना पड़ेगा. अगर आप imaginary part, y axis is imaginary part and x axis is real part. अगर आपको ये पूरा मेंटेन करना है तो 1 by twice 5 root of twice 5 से मल्टीप्लाई करना है. Why it is different upon the coordinate system. First quadrant, second quadrant, third quadrant and first quadrant. 1 by twice 5 स्क्वायर रूट अगर हम दोनों साइड से मल्टीप्लाई करेंगे तो क्या होगा, ये फर्स्ट एंड सेकंड क्वाड्रेंट में क्या होगा, ये सिमेट्रिक होगा. बेसिकली ये if I multiply it, जो भी क्वांटिटी आता है आफ्टर ट्रांसफॉर्मेशंस, it required more square root of 1 by twice 5. So I have to multiply 1 by a square root twice 5 on the both side. Then first quadrant and second quadrant दोनों में क्या होगा, एसिमेट्रिक होगा. इसका डिटेल्स में आप लोगों को इसका जो डॉक्यूमेंट्स है मैं अपलोड कर दूंगा. आप इसको if you read this one you can get how it is talking about the symmetry. Mainly Fourier transform become S plus actually omega plus I sigma. Omega is written here S. In beginning level we neglect the complex part. Again first and second quadrant अगर हम उसको सिमेट्रिक करना है तो 1 by square root of twice 5 is required. अगर हम इसको मल्टीप्लाई करेंगे तो ही ये सिमेट्रिक होगा. इसका मतलब ये है, बट दे आर नॉट डिराइविंग एनीथिंग हियर. ऑल दिस लेट मी सी हियर 41.5 दे आर नॉट डिराइविंग आई थिंक एनीवेयर हियर. वो लोग डिराइव नहीं किया है इसलिए ये कंफ्यूजन है. इस बुक में आई थिंक डिराइव नहीं किया है इन लोगों ने. नहीं, यहाँ कहीं वो लोग डिराइव नहीं किया है इसलिए आपको कंफ्यूजन हुआ है. They didn't derive here. उसका derivation में अपलोड कर दूंगा. Then you can get that why symmetric means you can get this one. Other than this, anyone, any confusion? Anyone, any confusion other than this?
Hello, sir.
Yes, tell me.
Sir, the example we solved that in last step.
Okay, last step.
Which formula is applied there?
This is sine.
Example number
Sine
7.
theta. Sine theta is equal to, we know this one, right? E to the power I theta minus e to the power minus. This is formula. Okay. How sine is coming, right? Last
Yes,
part.
sir.
This is the simple formula. Sine. Here, right? This formula, right?
Yes,
This
sir.
is. Sine theta is equal to e to the power I theta minus e to the power minus I theta divided by 2s I. ये sin theta का formula है. In the 10 plus 2 level, we have the formula sin theta is equal to e to the power I theta minus e to the power minus I theta divided by 2s theta. Means 2s I. ये साइन फॉर्मूला है. कॉस्ट का भी इस टाइप का है, बट हम उसको अरेंज करना पड़ेगा. लुक, देयर वाज नॉट 2s I, so what I did, I bring up this I this side and multiply 2i's, okay, and I put in the numerator 2 here. So I have arranged this one. It means this is a sin theta. Same thing, this become a sin theta, this one. Okay, so आपको ये एक बार स्टडी करना है. इंटीग्रेशन, trigonometrics, they are used here directly. Now is it clear? I think clear है अभी?
Yes, sir.
Okay. Anyone? Any more?
Sir, please stop the recording.
Sorry?
Stop the recording, sir, please.
I'm not getting.
Sir, I am telling that. Can you please stop the
Please
recording?
stop. Recording, sir.
Recording,
Okay.
recording.
Okay.